Example number 2. Solve the following equations by completing the square. Now in my first video, I just dealt with things, more specifically equations, that had b as 0. Let me just jog your memory. ax squared plus bx plus c equals 0 is a quadratic equation, but above, we only saw equations where there is no x term. So what we need to do is we need to use our sweet completing the square skills to be able to do this. So let's just start out with some easier examples when a, okay, the coefficient in front of the x squared term, is 1. So first things first, I want to isolate anything with an x. So x squared minus 10x equals negative 3. Now I'm going to see what number can be added to this side right here, and subsequently will need to be added to the other side to make this a perfect square trinomial. Remember our sweet shortcut here where we have b over 2 squared. So we can go, what makes this into a perfect square trinomial? So we have negative 10 over 2 squared, which is going to be negative 5 squared, which is going to be 25. So I'm going to add 25 to this side, but that means I also need to add 25 to this side. So let's get this into a factored form. This is going to be x minus 5 squared. That equals negative 3 plus 25 is simply going to be 22. So now this looks very similar to the last one that I did up here. The last one had that nice factored form already on the other side, but now the whole crux of this is that we need to get it into a factored form on this side. So I'm going to take the square root of both sides, so I get x minus 5 equals plus or minus root 22. So then I get x equals 5 plus or minus root 22. And this is our final answer. Now I'm not gonna get you to verify questions that I don't state it explicitly. So if you don't see verify in the question, then I will not require you to verify it. What about this one? So what we want to do is we want to isolate these. So x plus 4x equals positive 3. Oh, sorry, x squared plus 4x. What's the thing that we need to add to both sides that will make this right-hand side a perfect square trinomial? Ah, yes, plus 4. So then this will become x plus 2 squared equals 7. Take the square root of both sides. X plus 2 equals the positive and negative square root of 7. X equals negative 2 plus or minus the square root of 7. Done. What about when a doesn't equal 1 though? So the name of the game of this is I want to get this into, I want to get the coefficient in front of the x squared to be 1. So I'm going to divide each of my terms by negative 2, divide this by negative 2, divide this by negative 2, and we are going to have to deal with some fractions here, folks. I am so sorry. And also this side needs to be divided by negative 2. So then this becomes positive x squared plus 3 over 2x minus 7 over 2 equals 0 divided by root 2. Sorry, 0 divided by negative 2 is simply 0. Same thing, we're going to isolate the x terms. X squared plus 3 over 2x equals positive 7 over 2. And now we need to figure out that value that we need to add to both sides to get the the left-hand side into a perfect square trinomial. I'm just going to default to b over 2 squared. So my b in this situation is 3 over 2. So 3 over 2 squared. So then that's going to be 3 over 4 squared. which is going to be 9 over 16. So I wanna simplify this because it makes it very easy. So plus 9 over 16 plus 9 over 16. Because I'm going to say x plus 3/4 squared equals 7 over 2 plus 9 over 16. I'm just going to multiply both by 8. 7 times 8 is 56 over 16 plus 9 over 16. So then I'm left with x plus 3/4 squared is 65 over 16. I'm running out of space here, so I'm going to go right over here. So I take the square root of both sides. X plus 3/4 equals plus minus the square root of 65 over 16. Now I know what the square root of 16 is. Okay, I know that it's 4, so I can simplify that. X plus 3/4 equals positive negative the square root of 65 over 4. I'm going to subtract 3/4 from both sides. X equals negative 3/4 plus or minus root 65 over 4. Now, if I wanted to, this is a mighty fine answer. There's nothing wrong with that. But if I wanted to, I could, since I have common denominators here, I can say negative 3 plus or minus root 65 all over 4. Now that looks a lot like our quadratic formula answers, doesn't it?